Hello everyone. In this part, I want to show you the amount of greenhouse gases that is measured in the last 1,000 years. So, this scientists measure the concentration of greenhouse gases, and they went back to 1,000 years. How did they do that? They collected layers of ice from the Greenland and Antarctic. So as you go, for example, if this is the layer of ice, as you go deeper and deeper and deeper, you can measure the date of the ice. You know, it is called carbon dating. And carbon, you may remember from the nuclear chemistry topic, carbon-14 is a radioactive isotope, and every 5,000 years it has a half-life. So if you have 100 gram at the beginning, 5,000 years later it is going to be 50 gram. 5,000 years later, 25 gram. So you may remember this, and scientists are applying this carbon dating technique to find out the time of the ice, and carbon dioxide is trapped in the ice molecules. Since the solid ice particles has little holes in it, little bit carbon dioxide is trapped in it, and they start calculating the measuring actually concentration of carbon dioxide, methane, nitrous oxide, and sulfur from these Greenland and Antarctic ice particles. And what they observe is very interesting. The carbon dioxide level was constant for many years, but at point after 1800 we have a huge increase in the carbon dioxide concentration, and this side is the concentration of the gas, and this side is radiative forcing. Remember, radiative forcing is how much energy is trapped in the Earth atmosphere due to greenhouse gases, and it due to carbon dioxide it trapped this much energy is trapped. Nitrous oxide, let me tell you one more information that might be very obvious, and also you have watched the videos about the carbon dioxide cycle. So carbon dioxide is coming from the respiration, coming from burning, coming from using fossil fuels, and if we do the agriculture more, if we start deforestation, that is also a reason the carbon dioxide concentration increases in the air. So nitrous oxide, the source of nitrous oxide is industrialization. So when you start polluting air due to burning different types of gases, you are adding nitrous oxide to the atmosphere. So as you see here, after the industrialization here, after we start having as the human population increase, right, as we start using more industrialization, the amount of nitrous oxide increase, as well as the radiative forcing. Sulfur, the source of sulfur, you may remember from the sulfur cycle. The source of sulfur is volcanic activities and also industrialization. So we see lots of jumping ups and downs, since the sulfur concentration is very hard to control because of the volcanic activities. But at that part, apparently the industrialization is adding a big impact here. And methane is also coming from the industrialization that we are burning. And also you may find it funny, but the cow farts. are one of the biggest sources of the methane gas. So cow farting. So as we keep eating more red meat, if we have more farm animals, then they're also contributing this methane formation. That is one interesting, like that is this is why the environmental problems are so hard to solve. Why would like animal contribute to global warming? But that is what it is. And you see the impact of this methane on the global warming in the atmosphere. I'm gonna stop here, and I want to show you the cow fart video because you may find it interesting.
Animals that can eat grass have very unusual stomachs that have these bacteria that are methanogenic in there, and so they leak natural gas both out the front and the back. And so people have said, well, let's change the hay or throw some things in there. And nobody knows how to get rid of
No one how to get cows to stop farting.
Exactly, or burping. And so there is artificial meat, but that's at a very early stage. But that's another big source of greenhouse gas emissions. So, I'm just trying to make sure that the people who acknowledge the problem, which I think is fantastic, that they understand the breadth of innovation required before you can get anywhere near what we have to do, which is zero. If it was a 50% reduction, then you could ignore, okay, leave the cows alone. But because we're trying to avoid the temperature continuing to go up, you do need to go to zero. Otherwise, you're continuing to have temperature increase.